Scientific notation and conditional probability. Less objective, express and convert numbers in standard notation and scientific notation. Let's begin. Scientific notation, a method of writing very large and very small numbers using powers of 10. For example, a penny contains about 2 septillion, that is a 2 followed by 22 zeros. That is a very, very big number. On the other side, the average size of an atom is about 0.00000003 centimeters across. That is a very small number. And in both cases we see there's a lot of zeros to deal with. Scientific notation will make that easier. Scientific notation involves the process of moving the decimal point as many places as needed to move until there is only one value to the left of the decimal. The number of places the decimal needs to be moved determines the value of the exponent for the base of 10. We'll look at some examples. So looking at the number of atoms in a penny, in scientific notation that would be 2.0 times 10 to the 22nd power. The size of each atom would be at 3.0 times 10 to the negative 8th power. The sign of the exponent tells which direction to move the decimal. A positive exponent means you move the decimal to the right. A negative exponent means you move the decimal to the left. So this is a very large number. This is a very small number, and we look at the power of the exponent. The sign will tell us, do we move the decimal to the left or do we move the decimal to the right, hence making a larger number. Moving the decimal point to the left is equivalent to dividing by a power of 10, and moving the decimal point to the right is equivalent to multiplying by a power of 10. And this is why scientific notation uses the powers of 10, because in a sense that is just simply moving the decimal place. Here's a chart involving the number 1 written in scientific notation. 1 times 10 to the third is the same thing as 1,000. Notice if we start with the number 1 and we move the decimal 3 places to the right, we get 1,000. 1 times 10 to the 6 is 1 million. Notice if we start with the number 1, here's our decimal point, and from that if we move 6 places, the new decimal point is here, and that is the same thing as 1 million. Using negative powers, again we start with the 1, and this tells us to move 2 places to the left. So if I move it 1, now it's in front of the 1. If I need to move it 2, I need to add a 0 in front of the 1, and hence we get 1/100th. 1 times 10 to the negative 3 is 1,000th, and you see the general pattern. This is a lot easier to work with than this. This is what 1 million pennies looks like in physical form. So imagine if we're asked to find how many atoms are in all these pennies. That would be a very, very big number, and we would want to express that using scientific notation. So why is scientific notation important in statistics? Because many software outputs, say a cell phone or a graphing calculator or even StatCrunch, if the numbers are very large or if the numbers are very small, we have to be able to know what these numbers mean. And this is especially true when we start talking about what's called the p-value. Technology outputs like StatCrunch and many calculators may have a hard time writing scientific notation. As a workaround, the value of capital E, or sometimes capital EE, is used to represent times 10 to the, so whatever value is after the capital E, that will be the exponent for the power of 10. So for example, we have 3.897 times 10 to the 11th power, and some technology outputs would write it this way: 3.897 E and then 11. The The 11 is telling you that is the exponent. That is the power for the base of 10. Change this in standard form, we would have to move the decimal 11 places to the right because it's positive. So if we move this 1, 2, 3 places, we would have to add 8 more zeros for this number to put it in standard form. Here's another example. This is 4.9834 times 10 to the negative 5. And the output from technology may look this way. Again, there's no 10. Whatever is after the E, that is to tell you that is the power that you are raising 10 to. So to write this in standard form, I would have to start at the decimal and move it 5 decimal places to the left. I would have to add 4 more zeros and then the decimal point for this value. Here's an example. Write this value from this technology output in decimal notation, or sometimes that's called standard notation, to 3 significant digits. The first thing that we want to know is, okay, this is the power. So this is 10 to the negative 7 power. And we are multiplying that by this number, 1.585. So that's scientific notation. To write this in standard form or in decimal notation, I have to start with the decimal point, and I need to move that decimal point a total of 7 places to the left. So if I move it 1, this is now 0.1585. Well, I need it to move it a total of 7, so that means I need to add 6 zeros in front of this 1. So I'm going to put my decimal here. I need to add 6 zeros. 1, 2, 3, 4, 5, 6, then a 1, a 5, a 8, and a 5, and that is the number. This is telling me to take it to 3 significant digits, so we don't count the zeros. So 1, 2, 3. So that means I need to round this 8, and everything else to the right of that I drop off. So this number becomes 1, 2, 3, 4, 5, 6, 1, 5, 9, and that is the value. That value is a positive number, but is very close to 0. Let's do another example. This time we want to round it to 2 significant digits. So again, we look at the exponent. It's a negative 8. And then we are multiplying that by 2.097152. So again, I need to move the decimal point, which is here. I need to move that a total of 8 spots. So that means if I move it 1, I'm in front of the 2. I need 7 more zeros. So this is a very small number. 1, 2, 3, 4, 5, 6, 7. Then a 2, a O, a 9, 7, 1, 5, 2. Now 2 significant digits. I don't count the zeros, so I have a 2, a 0, and a 9. The 0 is the second significant digit. Either it's going to stay a 0 or become a 1. Since the number to the right of that is 5 or more, this is going to round up. So we have 7 zeros. 2, 3, 4, 5, 6, 7, a 2, and a 1. So that is rounded. That's a very small value, and as you can see, using all these zeros is time consuming, and it's very easy to get the decimal in the wrong spot. That's why scientific notation is a lot easier to work with. For this example, we're asked to write this in standard form to 4 significant digits. This is a 9.2 raised to the 12th power. This is the technology output. This time we have a positive exponent. So this would be 10 raised to the 11th power. And then our number here is 3.676663877. Our decimal is here. We need to move it a total of 11 places to the right. So if we move it 1, 2, 3, 4, 5, 6, 7, 8, 9, it would be behind that last 7. But we need 11, so that means we need to add 2 more zeros. And there would be our decimal place. Now you can always double check this by starting at your decimal point and counting this way. You should count 11 places. Here's another example. The speed of light measured in miles per hour is 671 million. Write this in scientific notation. Well, we need to move the decimal from here all the way to here, so there is one number to the left of the decimal, and it can't be a 0, so this is not a 0, so that's fine. So we need to know how many spots do I move from here to here. Well, this is 3 and this is 6, 7, 8, so the power is 10 to the 8th. So writing this in scientific notation, we would say 6.71 times 10 to the 8th power. For those of you that play poker, the probability of getting a royal flush in a 5-card poker hand is 0.000000154. Very small probability. Write this in scientific notation. So this time we want to move the decimal from here to here, in between the 1 and the 5. So we need to move it 1, 2, 3, 4, 5, 6, 7. So that is going to be 10 raised to the -7 power. And again, we can always double check our answer taking our scientific notation, and if I move this decimal to the left, because this is negative, 7 places, I should get this number. Here's our last example for this video. We have a table where we are actually asked to convert the standard, and it's labeled actual value, and then we have scientific notation, and then we have calculator notation or technology notation. So let's begin with the second line. This is 3.75 times 10 to the 6. So the technology output would be 3.75e, and then we put the power, 6. To write this in standard form or decimal form, this 6 is positive. It tells me I need to move the decimal 6 places to the right. If I move it 2, it is in front of the 5. I need to move it 4 more, so I need to add 4 more zeros. 1, 2, 3, 4, and there is the decimal. Next, row 3, we have 5.834 e to the 11. That's 5.834 times 10 to the 11th power. That's scientific notation, and we need to move this 11 places to the right because it's positive. If I move it 3 behind the 4, so that means I need to add 8 more zeros. So that would be 5, 8, 3, 4, and then 8 more zeros. 1, 2, 3, 4, 5, 6, 7, 8. Again, that's a big number. Next, to write this in scientific notation, our first number is going to be a 4, then our decimal, and then 6 and 8, and then the rest are zeros, just placeholders. So we don't need to write that, and that's 10 to what power? It's here, we're moving it to here. How many spots is that? If I count this way, this would be 1 plus 3, that's 4, plus 3 more, that's 7, plus 3 more, that's 10. So this would be a power of 10. And technology output, this is going to be 4.68 e to the 10. Next, we have an exponent of -5, so this in scientific notation be 4.382 times 10 to the -5 power. So this time we have to move the decimal when we write it in standard form 5 places to the left. So that means I need to add 4 zeros after the decimal. 1, 2, 3, 4, and then 4, 3, 9, 2. This problem, this is 1.2368 e, do not forget your negative, -8. In standard form, I need to add 7 zeros after the decimal. 1, 2, 3, 4, 5, 6, 7. Then the 1, the 2, the 3, 6, and the 8. And the last one, so we need to move the decimal from here in between the 3 and the 5. So we have 3.555 times 10 to the, okay, I'm going to count 1, 2, 3, 4, 5. So that would be 10 to the -5th power. And again, it's negative because we're saying the decimal's here, and in standard form it's here. So how many places do I need to move it from here to here? And again, we can always double check these and verify our answer. And the technology output, we would have 3.555 e to the -5. Well, e -5. Thanks for watching.